Yeah, next thing is what now? N2 minus 2. N2 minus 2 molecular anionic species has how many electrons here? 16 electrons. Okay. So for this 16 electrons, we have to write molecular orbital electronic configuration. That means these 16 electrons are to be distributed into molecular orbitals. So what is the order of nitrogen molecular species? Sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. After that, pi 2px equals to pi 2py. These two are degenerate orbitals. How to fill one electron here, one electron here, again one electron here, one electron here, like this. After this, sigma 2pz with 2 electrons. So up to this, 14 electrons completed. Still, we have 2 more electrons. The 2 more electrons will go to pi 2px 1 electron, pi 2py 1 electron. So here up to this, how many electrons completed? 8. 8 plus 4, 8 plus 4, 12, 12 plus 2, 14, 14 plus 2, 16. So it is what molecular orbital configuration for N2 minus 2 species. Next one is what? Intermolecular hydrogen bonding. So between the molecules, hydrogen bonding is example what now? Example for this type of bonding what? HF molecules, ammonia molecule, H2. So any one of these you can mention. Anyone you can mention of these. Next, intramolecular. So intramolecular meaning what? Within the molecule. Intra meaning what? Within the same molecule, between two atoms, the hydrogen bonding is called what? Intramolecular. Hydrogen bonding is generally what? Between hydrogen atom and more electronegative atoms such as fluorine, oxygen, nitrogen, and sometimes chlorine. So here intramolecular hydrogen bonding. So it is what now? Orthonitrophenol and orthohydroxy benzaldehyde, orthohydroxy benzoic acid. So in this here, between what now here, within the same molecule, hydrogen bonding will be there. So between here hydrogen and oxygen, between hydrogen and oxygen, between hydrogen and oxygen. So what will be there here? Hydrogen bonding of which type? Intramolecular. Intra means within. Next, the fourth one is what? State Boyle's law. What is the numerical value of R in joules? What are the graphs plotted at constant volume called? 1 bar is equal to how many atm? 1 bar is equal to how many Pascal? So here first one, Boyle's law states what? The volume of a given mass of gas is inversely proportional to the pressure. Inversely proportional to the pressure at constant temperature. And R value in joules how much? 8.314 joules, Kelvin inverse, mole inverse. And ISOP 4 is the graph which is plotted at constant volume here. And 1 bar is equal to 0.987 atm. 1 bar is equal to 1 lakh pascals. 1 lakh means 10 power 5 pascal. And the last one is what? A weather balloon. Balloon means what now here? This one. A weather balloon with the hydrogen at given temperature and given pressure has volume equal to this one. So what are given here? V1, T1 and V1, T1 and P1 given here. So what are the given initially? So P1, P1, T1, V1 given T1. Right now. On ascending means on going to the height, on going to particular height, on ascending, it reaches a place where temperature is minus 23 degrees Celsius. The balloon has reached the place where minus 273 degrees Celsius is there. But initially temperature, how much it was? 27 degrees Celsius. At present, it is what now here? Minus 23 degrees Celsius at higher altitude. Okay, and the what your pressure changed here. The pressure has become what now? 0.5 atm. P2 is given like this. And calculate the volume of the balloon. So V2 of the balloon we have to calculate. Final volume of the balloon we have to calculate in what? Liters. And standard ambient temperature pressure conditions. Mention SATP conditions. SATP means standard ambient temperature and pressure. So from the given data, P1 is given, V1 is given, T1 given, and P2 given and T2 given, and V2 we are asked to find out. V2 value we are asked to find out. Then V2 is equal to what? P1, V1, T2. Cross multiplication you have to by P2, T1. So like this, what now here? P1 value 1 atm, V1 value 1200 liters, and T1 given how much? 27 degrees Celsius now. We have to convert to Kelvin. 27 degrees Celsius plus 273 Kelvin. And here, and what is the P2 given? 0.5 atm. V2 we need to calculate, and temperature given what? Minus 273. So minus 273 plus 273. Minus 273 degrees Celsius plus 273 will give what? Kelvin temperature. So we got Kelvin temperature. So on solving this, we get V2 is equal to 20,000 liters. 20,000 liters. And next last one is what? Standard ambient temperature and pressure conditions, what? Room temperature 25 degrees Celsius or 298 Kelvin. 298 Kelvin. And 1 bar pressure we can write, or nearly 180 we can write. Both nearly same, not exactly same but nearly same. So 1 bar or 180, anything you can mention here. And also 298 Kelvin or 25 degrees Celsius we have to mention. So this is what now here the paper discussion on screening test. Okay, so today's screening test paper is okay, bye. Bye. Good day.